Hello, welcome to the Semantics lecturelet introducing functions. So in this lecturelet, we will see how functions work. Functions are important for semantics because they will be the key engine of saturation and making composition work. Now, a function is just a mathematical concept. It's a type of relation that maps members from one set to precisely one member of a second set. So to take a very simple example from math, if a function in 1, f of x equals x squared, then you'll take x and it will give you x squared. So if you give it 2, it gives you 4. You give it 3, it gives you 9. You give it 4, it gives you 16, and so on. So when you plug in each number, the function refers to a specific number. F of 2 will give you 4. F of 3 will give you 9. F of 4 will give you 16, and f of 9 will give you 81. You can go on forever like that, right? Because the set of numbers you could feed into it is infinite. Each function can be thought of as taking two sets and linking them together by mapping members of one to members of the other. The set of possible inputs to the function is called the domain, and the set of possible outputs to the function is called the range. And in essence, then, every function will map each item in the domain to exactly one item in the range. So the domain 2, 3, 4, 9, and the range will have 4, 9, 16, and 81. And you can use functions for math all over the place, but you can use them really for any kind of functional relation. So in 4, we have f of y is the capital of y. And then if we plugged in, say, Kansas, Nebraska, and Oklahoma, we would get the function, or the result, in the range, Topeka, Lincoln, and Oklahoma City. And in that sense, we can say that the domain is the set of states, and the range is the set of cities. So we say that a function maps from its domain to its range. The domain is the set of states in this case, the range is the set of cities. And we can define functions in that way. We'll say f, as in f for function, the typical variable for function. F maps from the set of states to the set of cities. And we can write that in a notation like this, where f colon, f is a function that maps from the set of states to the set of cities. So this colon would tell us maps from, and then the arrow is read as to. Inputs can share an output. That is to say, not all functions are one-to-one. So for instance, f of z, if f of z equals z's hair color, or the hair color of z, well, there's an infinite number of people, not an infinite number, there's a huge number of people in the world, but there are only a handful of hair colors. So we're going to have to share. So let's suppose that the domain in this example is small. It has the set of friends, Bob, who's blonde, Terry, who's brown-haired, and June, who's brown-haired. So we can take this function, f, and it maps from the set of the domain, the set of Bob, Terry, and June, to the set of x such that x is a hair color. That is to say, from this set of people to the set of hair colors. And it will do so like this, because Bob is blonde, Terry is brown-haired, June is brown-haired. So in that sense, we can get a mapping, we can get all sorts of mappings any kind we like. So to summarize, a function maps from one set to another. The input set is the domain, the output set is the range, and the function maps each input to one output.